Anyway, hello everybody. I'm with Pierce County Planning and Public Works, and specifically I work in the Road Operations Department, which is a little different than our Water Quality Department. So I'm working more from the standpoint of the pavement side than the permeable side. And this is what we have learned so far and the questions that we have when it comes to how to take care of it and how to make it work moving forward. So throughout this presentation, permeable, pervious, and porous are going to be referred to as the same thing. There's just a lot of P words involved in this particular subject, so bear with me. And I'm going to be going fairly fast through the beginning portions just because the maintenance is the more interesting portion of this, and much of this information is available through either the Stormwater Management Manual for Western Washington or through your permits themselves. Sorry about that. Ooh. Okay. Need to wait for the reverb. Okay. So first of all, I'm from Pierce County, which is the highlighted portion, and I am not an expert on pervious pavement. This is just something where I have some experience in a very specific portion of this, but this is something that we're kind of all learning together at the same time. So I wanted to share what we know, and we have a lot of questions coming up for what pervious pavement is and how it fits into our environment. So we're trying to experiment to learn how to make it work. And some of this might seem a little bit negative going through, but it's just because there's so many things that we don't know. But we aren't going to know until we try it and figure it out. So part of permeable pavement is that there are competing needs. We have the needs of being a stormwater facility and the needs of being a roadway. So some of the objectives for what we're trying to do. There's the more surface water side of things where we're trying to reduce the pollution, and we're trying to take care of the water quality by either filtering or intercepting. But we're also concentrating the impact, because anytime you have a paved surface where you are directing people where they should be, you are protecting the environment around, like the plants grow by the inch and die by the foot statement that goes along with a lot of trails. But we're also trying to provide physical access. We need to make sure that whoever is using this, whether it's pedestrian or vehicles, that the weight can be supported, that the slope is appropriate, that they aren't going to slip off, and that there isn't stuff in the way. We're also trying to meet the regulations, which are the environmental regulations, yes, but also getting down to a lot of the transportation regulations and labor regulations. So getting into feasibility, this is where we're trying to move from being competing functions to try to be collaborative, try to be able to work together. So in Western Washington, pervious roads are required in many situations. If you can't get 65% of your site to remain as forest, and you don't meet any infeasibility requirements, and you don't have technically defined competing needs, then we are required to do it. Considering that we are roads, very often we can't dedicate 65% of our site to remain as forest. These competing needs, we'll get into that a little bit later. One thing that I have been told since I put this presentation together is that when it comes to federal rules, sometimes those will trump over some of the requirements for when you would need to do the infeasibility, or for when you would have to otherwise do pervious pavement. So hopefully we find other things that work in those situations where pervious pavement just is not going to be an appropriate solution. So the first bullet points are going to be what the manual states for what is infeasible, and then going into the other concerns that we have or we have seen or are concerned about coming up in the future. So the other concerns for the point of climate is just in some locations, probably more so in Eastern Washington than in Western Washington. If you have a cold environment, there's a possibility of experiencing frost heave in the roadway as water gathers underneath the road and then freezes. Groundwater. Our big concern here is we have one cul-de-sac where there is a sanitary sewer manhole and there's cracks all around it. And one of the things we're wondering is going on is possibly enough water is getting down below that it's actually causing the structure to become buoyant and it might be trying to move its way out. We are monitoring this, and we did have the sewer people get out and have a look to make sure that it isn't causing any stresses and potentially releasing raw sewage into the groundwater. Soils seem to be pretty well covered. Slope. We do have some concerns when it comes to subsurface pollutant transport. So if you have a road that slopes to a low point, it might be a quarter mile away, who knows, and you were to get a spill, is that spill going to transport through that subbase, and are you going to have a large linear area that you're going to need to cut out to be able to mediate that spill? Contaminants are also listed. Pollution generation. We don't know exactly what to do with contamination from traffic collisions. Luckily, we haven't actually had a traffic collision on a pervious surface yet, so we haven't come to this crossroads yet. It's just something that we know is coming. Adjacent features. We found a couple things going on when it comes to adjacent features. One is that if there are shadows, such as if you have a tree, there tends to be a lot of moss buildup that will develop on the roadway. We've also found if you have a fir tree anywhere even remotely near your facility, you're going to end up with fir needles in your surface, which is fine. It just takes cleaning. And this is a little bit embarrassing, but when this was designed, it was not noted until after it was constructed that there is a transition from having a crowned roadway to being a flat roadway. So the picture here is what happens when you have the edges of your traditional pavement down below where your pervious pavement starts. Traffic loading is another feasibility criteria. This is something that we haven't really seen addressed too much. It comes down to friction. So we found in areas where someone has to stop or dry steering that there tends to be a lot of pulling away at the pavement itself. So this picture here is a 7-year-old pervious concrete. And you can see that there are patches and areas that have been pulled out that will need to be repaired as well. If you see the competing needs portion of the SWIM manual, you'll see a little bit of information on exceptions for ADA access. So this does, as far as we can tell, give us the opportunity to use traditional pavement for ADA access ramps, which don't seem to handle the slopes as well. And we've also had apparently some difficulties with being able to support our equipment that manages the storm or the lights that will be at these intersections. There doesn't seem to be any feasibility for access, and this can be a concern when you have some physical, safety, legal, or privacy reason why you don't want your people to be going in and doing some sort of inspection, or where cleaning is not going to be conducive to the use of whatever the site is. And this tends to come into play when you have a facility like this. This is a power substation. It's not ours, but it's a power substation. Or any military installations, or possibly a railway. All right, getting into materials, we haven't really learned that much about materials, we as road operations. But I did find one study that said that crushed aggregate was better than rounded aggregate as far as establishing compressive strength. So that might give you the ability to use this with heavier vehicles. Storm system. So directly from the BMP, it does say, roads should still be designed with adequate drainage conveyance facilities, as if the road surface was impermeable. This is really important to us, or at least it was very important to us when we didn't understand how to clean it properly, because when we don't know what we're doing, it's very difficult to assume that we're not going to need to be able to get the water somewhere. It also works as a very nice overflow for if something does go wrong. Installation. The BMP does go over in detail some of the treatments for how to treat the ground. One thing we've come across is that you need to have a cool enough environment for the concrete, cool enough weather, so it doesn't overheat. And also need to make sure it's warm enough and close enough to an asphalt plant if you're going to do asphaltic pavement. This can be a concern, especially when you're trying not to compact your surface in your construction, to make sure you're going to be able to get it there on time. Otherwise, you're going to end up with a very flaky surface. Also, scheduling and getting hold of qualified labor. I don't know if this is true everywhere, but in our area, there doesn't seem to be that many contractors who are available who actually know how to work with this and have the certifications that we ask for. Inspection. We actually found that the inspection was about the same as far as frequency, how often we needed to be out there. Maintenance. All right, so when it comes to maintaining porosity, we especially didn't know what we were doing at first. So the picture that says 2 years, that is one of our facilities we had been trying to clean, we just didn't know how. And the one that says 3 years is not our facility. So we tried several different methods. These are the 3 methods that are given in the manual for how to maintain the pavement. And these are what we tried. We ended up going with the one that's circled in purple. And I don't know how clear it is from back there, but the man walking in that picture, he's actually walking on pavement. That's moss that's developed in the pavement. And that's what one swipe of this machine did. And we're finding that it is actually restoring the porosity very, very well. So this is another view of what we tried and why we chose what we did. So the infiltration improvement ranged quite a bit. Some were pretty low. The pressure wash, we actually had a couple situations that seemed to be negative, like the infiltration rate after was worse than it was before we cleaned it. And we're thinking that possibly it was actually driving some of the clogging material down deeper and creating a better seal to keep the water out. And then there's efficiency of use, because some of these took an incredible amount of manpower and took a lot of time to maintain or to do the cleaning itself, and had to stop frequently to go back to a facility to be able to dump the water properly to come back and start over. So we ended up going with the municipal cleaning vehicle. And this is a spray cleaning and recovery vehicle. So, snow and ice experience. So the manual and several other, yes?
I'm sorry, before we move on, how much did that cost?
$250,000 a year, or $250,000, and we only use it about 2 weeks a year. So I'm going to get into that and trying to create agreements to make that cost a little more bearable for everybody. So, going back to this slide. We've heard that with snow and ice, it should be better than it is with traditional pavement, though that really hasn't been our experience. So you can see in the picture here, there's a 1 foot wide collar that's made of traditional concrete. And right next to that is the porous concrete. So in the areas where people are not driving or parking, we did find that the snow was making its way off of the traditional concrete faster than the porous concrete. Here's another picture of the same intersection. And I know you really can't completely see the conventional concrete, that 1 foot wide collar in there, but this is the difference between the asphalt and the previous concrete. We hadn't maintained this at all for stormwater. I mean, for snow. We haven't been plowing or applying any materials to this. But we are wondering if possibly it could be better for reducing black ice, because the water wouldn't be freezing on its way down. But we are finding that the snow makes its way off of traditional pavements probably a little bit better than it does with porous. which I know is contradictory to everything I've read on how it should work. We did find one group that put together some detail on how porous pavement should be maintained for snow and ice. And it basically comes down to don't use sand and consider organic de-icers, and also just placing your snow blade slightly higher. Spill response. We just don't know exactly what to do about spill response. It's something that we're hoping that people will be encouraged and we'll get more groups together to try to figure out how to handle this. One just concept that we're hoping can help us is possibly being able to place some sort of coagulant in the road base. So if there is a spill, maybe it can be contained inside the pavement and not transported into the groundwater or further down the road. And we don't actually have a very good definition for any threshold to define spill. So we're not sure what is a leak, what is a spill, what is actually going to require us to dig out the road. Utility patching is addressed, though it's a little bit ambiguous. We did find in the Green Roads Manual they had a threshold of 50 square feet, where if you're removing under 50 square feet, you could potentially put back traditional pavement, which is easier for us just because our people are not trained on how to install porous pavement. Again, we're road operations, so we're talking like potholes and when you're replacing a catch basin, that sort of thing. Pothole repair. We're hoping patching mix means the same patching mix we've been using traditionally, but we're just not sure. Crack repair. There is the ability to patch small cracks with patching mix, but large cracks require cutting out and replacing. This is a picture of one of our parking lots in impervious pavement, and this is at 3 years, and I don't know how you can see it, but there's a big crack across and one leading into that, leading to preservation. Typically, we have to do something, some sort of seal coat or overlay in 12 to 15 years with regular pavement. We don't know exactly what the time frame is with pervious pavement, but this picture here shows that we have seen raveling at 1 year, and this is from a garbage truck that had to stop and turn throughout this cul-de-sac. Seems to tear up the surface. Pavement marking. We're not exactly sure how we're supposed to be marking these pavements. We do have one arterial that we did do impervious pavement. I know it's in the infeasibility criteria. It was trying to figure out how to make it work. And we ended up using just raised pavement markings. We weren't sure how the pavement would take any sort of paint or thermoplastic and if it would stay. Also, we didn't know what chemicals would end up getting into the groundwater in this system. There's another group that did the only sign. You can see in here, and you can see it's sort of wearing through after about a year. Long-range planning. So, in your design costs, I think it might be helpful to include mapping the infeasible regions just so that your design staff and review staff won't have to spend as much time reviewing these things, so it makes it clearer to especially private developers when it is and is not feasible to have it in place, and having to find out what your availability is of the equipment and the labor, making sure that you have people who can install it. Creating a contingency plan for stormwater overflow, which if you have a traditional conveyance system, should be just the same as a normal road. And potentially establishing access easements for inspections, which really depends on how your group decides to handle the inspections of private properties and how they want to handle informing the property owners that they have a responsibility to let people inspect them. So when it comes to installation costs, none of this is our own research. This is just some information we found, trying to put it in the pool of where we're starting. But it looks like up to 150 times, or 150% of the installation costs of traditional pavement. So, M&O preservation costs. For our municipal cleaning vehicle, it travels at 0.15 miles per hour, and it has to stop to take care of business. So this will take some traffic control and some potential road closures when it comes to busier roads. It's also, I believe, 5 feet wide, so it'll take a couple sweeps to be able to get through your area. Also considering cost and access to things like the cleaning equipment. The reason we purchased our municipal cleaning vehicle is because we couldn't find it available for rent, or at least not consistently. Getting hold of your snow and ice treatments. If you're going to be using these organic de-icers, what are you going to use? Where are you going to get it? And can you get it consistently? Finding small batches of material, and also finding the labor to be able to do so. One idea in there is considering training your staff for doing those repairs. So for potholes, for small repairs. And we're not really sure about the design life, some of the repair methods, how to contain spills, and how long it's going to stay porous even with cleaning. So please don't panic with these numbers at first. So this is our numbers from 2016, scaling them by our areas, and this is for if the county was suddenly completely 100% porous pavement, what the cost would be. So it's intense, but a lot of this is just we need to find something to do other than digging it out and starting over every time that the roadway needs some sort of treatment or you get a spill. So when we get that taken care of, this number will go down drastically. So please try to find ways to help. And if you'd like to see these numbers, you can email me. I'll send you the results of where we got this from. And this is assuming the same rate of decay that we have for traditional pavement. Funding considerations. Please verify that your funds are being spent appropriately. And this gets slightly tricky in my view, which I don't work this directly, but we have our road or street funds, and we have stormwater fees. And confirming that you're spending those in ways that aren't going to be a problem later. Impacts to stormwater fee revenue. If you are assessing your stormwater fees by impervious surface area, and people are putting in impervious or pervious pavement, then you are going to see somewhat of a decrease to your stormwater fees. So just be aware. Also, grants might be available which could help offset these costs. Risk considerations. So there is a possibility of experiencing groundwater contamination. If we have the exhaust and other things that are coming off of roads making their way into the groundwater, it could end up in drinking water. Increased groundwater elevation. If we're putting water into the system, it could make the groundwater raise in other locations. That's why we have the underground injection control facilities anytime you're putting water into the ground. Flooding. So this also gets down to groundwater. We have one area where there's a basin where when it gets storm events, it's fine. And then 2 months later, we get a lot of flooding in another location. So just be aware the more water you put in the ground, it goes somewhere. It could be seen politically as a boondoggle if this turns out to not be sustainable, which is part of the reason we need to find ways to make this work so it doesn't become a problem. You could potentially be accused of improper maintenance accusations, which is difficult since in some ways we don't know how to maintain things yet. We just figured out how to do the porosity. So consider defining your maintenance by action, not by result. Another suggestion is combining forces. It might make sense to combine or stagger your contract timeframes, especially if you have a shortage of qualified contractors. That way not everybody in a region is trying to get the 2 contractors that you have to do their 8 projects at the same time. Rent or share equipment. This is going into like how Pierce County would like to try to get other people to join in and for use of the municipal cleaning vehicle. And you can please talk to me or email me if you're interested in doing that. But some of this equipment is just very expensive, so it can save a lot of money for everybody if everybody joins together. And please share the lessons you learned so that we aren't repeating the same mistakes over and over again. And, right.